First, we open a new Microsoft Excel file in blank. As a second step, we locate our file where the program is nested and click to open it. Once inside the program, we see a black interface and press the Initiate button. We enter our password and accept. The Smith and Ichiyen button becomes active. We press it, and it shows us a form of the program. To start, we position ourselves on the right side and press the Empty button. We do this to eliminate all the flotation stages that might have been used in any previous stage. We add the flow, in this case 70,000. The unit of flow is always metric tons. We have a control where we can decide if there is the possibility to choose if the entered mineral comes from a previous flotation or comes from milling. The mineral is in this case is, as an example, copper. However, we can also write it. The unit of concentrate grade is percent, or ounces per metric ton. We always use metric ton to match the flow units. Now we see our flow sheet and reconcile the existing flotation stages. We proceed to enter the flotation stages: rougher plus scavenger plus cleaner 1 plus cleaner 2 plus enter, cleaner 3 enter, cleaner scavenger enter. We can use the active buttons to edit the names in case we have made a mistake in typing them. We can move them up or down and even delete them in case of error. Once we have correctly entered the flotation stages, we press the Go to Balance button. We see a window where we must enter our flow sheet. We choose each of the flotation stages to place their feet. We choose rougher, which is the first stage the flow sheet enters. We see what its feet are. We must be careful here. What is entered in this form are the inputs of the stages. We choose rougher and see our flow sheet. The feet is the milling. So we choose milling over in this drop down and press the plus button. We choose scavenger and see our flow sheet. The feed is the tailings from the rougher stage. So we choose RLV rougher in this drop down and press the plus button. We choose cleaner 1 and see our flow sheet. The feed is the tailings from the cleaner 2 stage and concentrate from the cleaner scavenger stage. So we choose CONC cleaner scavenger and RLV cleaner 2 in this drop down and press the plus button. We choose cleaner 2 and see our flow sheet. The feed is the concentrate from the cleaner 1 stage and the tailings from the cleaner 3 stage. In addition, concentrate rougher 1. So we choose CONC rougher and CONC cleaner 1 and RLV cleaner 3 in this drop down and press the plus button. We choose cleaner 3 and see our flow sheet. The feed is the concentrate from the cleaner 2 stage. So we choose CONC cleaner 2 in this drop down and press plus button. We choose cleaner scavenger and see our flow sheet. The feed is the tailings from the cleaner 1 stage, so we choose RLB cleaner 1 in this drop down and press the plus button. Now we enter the grades of each flotation stage. We choose rougher, which is the first stage the flowsheet enters. The value according to the flowsheet is 0.69%. Then the concentrate grade is 15.39% and the tailings grade is 0.1%. We choose scavenger and see our flowsheet: concentrate 1.40% and tailings 0.09%, and press the plus button. We choose cleaner 1 and see our flowsheet: concentrate 8.66% and tailings 0.36%, and press the plus button. We choose cleaner 2 and see our flowsheet: concentrate 25.83% and tailings 0.2%, and press the plus button. We choose cleaner 3 and see our flowsheet: concentrate 33.16% and tailings 0.2%, and press the plus button. We choose cleaner scavenger and see our flowsheet: concentrate 4.39% and tailings 0.12%, and press the plus button. In the left panel, we can observe all the chemical laws for each flotation stage, which allows us to keep track of the entered data. Then we press the Generate Equation button. We can see that the program has generated the mass balance metallurgical equations, the equation specific to each flotation stage, and the V matrix for carrying out the Smith and Ichiyen procedure. We press the mass fractions button, and the program calculates the initial fraction from the same chemical grades as a reference. Their values can be perfectly corroborated with solver. In the end, we press the Smith and Ichiyen button and see how it performs until it returns a metallurgical balance report. We can retrieve the result by entering our password, pressing the button, and enabling Microsoft Excel. We position ourselves in the top left corner, select everything, press copy. In the blank sheet, we passed everything that the program returned. To be able to balance the other metals that accompany the metal under study, we only need to generate a copy of this balance, change the name of the sheet to the metal desired, and in this place change the grade to be able to estimate their balance values. For example, we have iron as another metal different from copper, which is the main element of the circuit. According to the laboratory report, the following iron grades are listed. We select the iron grades from the laboratory report and paste them into these sections, and the balance automatically adjusts for iron. Obviously, we must manually change the iron units because this does not happen automatically since the entire balance is centered around copper. And observe how the objective function has automatically adjusted the iron grades. Now, if we wish to use the information from this balance, we can draw our flowsheet on a new sheet and simply pull the information we have. If we draw a flotation cell, we simply have to pull the data from our balance, whatever data we may need, the correct grades or the masses that we might need. Okay, that's it.